It's time to study the third programming language in PLC, and that is the SFC language, Sequential Function Chart, where I, in this first film, will show an example of a sequence and the fundamentals of the SFC programming language. Then in the films after that, I will show how to build SFC programs in codices. So far, in the program examples I have used, everything has been executed immediately. But in many cases, we want things to happen in a set order, in a workflow or in a sequence. We can describe sequences in different ways as flowcharts, sequence diagrams, state machines, Petri net. I will focus on the sequential function chart. As an example of a sequence where we need to have things happening in the correct order, I have used the program of an elevator. The elevator program needs to start by checking in which direction the elevator should go. Are there orders for going up or for going down, or maybe both? And then the program should make a decision on in which direction to go. Then it starts the elevator in the chosen direction. While the elevator is moving, the program needs to check if the elevator has reached the ordered floor. While the elevator is not on the ordered floor, it should continue to go. When the elevator has arrived at the ordered floor, the elevator should stop and the order to that floor should be cancelled. Then the program needs to open the elevator doors, and the doors should continue to open until they're fully opened, which means that the program needs to check if the doors are open and continue to open them until they're open. Then the program must wait for people to enter or leave the elevator, and then the doors can be closed again. We must continue closing the doors until they are fully closed. When the doors are closed, the program can go back to checking the direction of the new movement. This is an example of a sequence. Things have to happen in this order. We should not try to open the doors while the elevator is moving, or start moving the elevator while it's waiting for people to come in or out. For the program to work, the sequence needs to be working together with another program, which is checking for buttons pushed, and then make the orders, turn on lights, turn off lights. That part of the code needs to be run continuously, regardless of where we are in this sequence. People should be able to make new orders regardless of if the elevator is moving or the doors are opening. This part of the program could be written in FBD or ladder, for example, and so could this part of the program, but it's often a good idea to try the SFC programming language for this type of sequence. If we could write the program as a sequence in words, as like in the previous slide, as a flow chart or maybe a state machine, then it's a good idea to consider an SFC program. I will show an example here, both as a state machine and as a flow chart, and then I will make an SFC program out of it. In this program, we have a machine that can move either forward or backward, or not move at all, as in the idle state, the starting state here, as we see in the beginning of this state machine. And here we have the flow chart that starts with the stopped process. Driving forward is false and driving backwards is false when we are in the idle state. Here the program is waiting for a button to be pushed, button 1, that gives an event in the state machine, and it's also checked here in the flow chart as a question: is button 1 pushed? If it is pushed, we are moving to a new state in our state machine where forward is true, and we can see that also in the flow chart. If the button is pushed, yes, then go forward. we should continue going forward until the front sensor is activated. Is the front sensor activated? Yes. The process should be stopped. If not, continue going forward. And here we remain in this state until the event front sensor is active, and then back to idle process. This machine should go back if button 2 is pressed and not button 1 at the same time. Then it moves to the state going backward. And in the flow chart, if button 1 is not pushed, then it checks, is button 2 pushed? If no, just remain stopped. If yes, start going back. And the process should continue going back until it's at the back sensor. Then it goes back to the stop process, and we can see the same thing in the state machine here. In a sequential function chart program, the same program is described here. We start here in the initial state, in the init state, where the process is stopped. It waits for button 1 or button 2. In the SFC programming language, this is called a transition. It's something that needs to be true for the program to move from one step to another, just as in the state machine. If button 1 is true, then the program goes to the step forward, where it performs an action, where it drives the motor forward, and it will continue performing that action until the next transition is true. When that transition is true, the program goes down to the next step, or in this case, a jump, back to init. We can see here as well, we have a vertical line here, and that is the choice between button 1 and button 2, as here. If button 1 is not pushed, then we can check for button 2. And the same goes for the program here. If the left transition is not true, then the program is checking for the next transition. This is an alternative branch. The program can go either this way or this way, but it can't jump from here to here. It will continue running the motor back until the sensor back is true. For the action here, we have a qualifier, an N. This N means non-stored, which means that this action will be activated while the program is in this step. All those representations of the same program will come back to the idle position, and we should try to write the SFC program like that as well, for the program to come back to the init position while waiting for the next thing to happen. I showed the action here. There is an N in front of the action that is performed. We have a few more qualifiers we can use. N for non-stored. That means that the action is active as long as the program is in that step. We can use an S, that is stored, which means that the action is activated when the program enters the step, and then it remains active when the program leaves the step until it gets to the qualifier R in another step. Then the action is reset in that step. We can have a time-delayed activation of the action. If the program is still in the step after the set time, the action will be activated. We can also have a time-limited action. Then the action is activated directly when the program enters the step, and then it will be deactivated after the set time if the program is still in the step, or it will be deactivated when the program leaves the step. The P for pulse, and we have different combinations of time-delayed and stored, and time-limited and stored. All the qualifiers with a D or an L, they need to have a set time. That set time is written together with a qualifier, for example, D space T hashtag 5M for 5 minutes. I will use the coming films to show how to write an SFC program in codices. In the first film, I start with the alternative branch, as we saw in the example, and also how to write a parallel branch. In the film after that, I will use some of the qualifiers, and how to make actions and transitions that are subprograms of the SFC program.